Hello friends. Welcome to Dr. Rajendran's online academy. The course title is Physical Chemistry, and the specific topic is thermodynamics. Let's move to the classroom. In this class, we are going to learn about the terms, such as thermal energy or heat, work, and internal energy. These are the terms that we are going to use in the first law of thermodynamics. Therefore, the basic understanding on these terms are necessary. First, let's see what is the thermal energy or heat. Heat is the amount of internal energy entering or leaving a system. It occurs by the processes such as conduction, convection, or radiation. It causes a substance's temperature to change. It is important to note that it is not the same as the internal energy of a substance. Heat always flows from warmer to cooler objects. If thermal energy flows into a system, it ultimately increases the internal energy of the system. So, it is positive. If heat flows out of a system, it will lead to the decrease in its internal energy. Therefore, it is negative. Work is a fundamental physical property in thermodynamics. Work is done to achieve motion against an opposing force. Examples of work includes the process of raising a weight against the pull of gravity, and the expansion of a gas that pushes out a piston. Work is an interaction between a system and its surroundings, whose equivalent action can be the raising of a weight. In simple words, work is one way a system can interact with its surroundings. Another way a system can interact with its surroundings is by means of heat transfer. Here is the summary of heat and work. They both are recognized only at the boundary of a system. As they cross the boundary, they are associated with a process, and not a state. Unlike internal energy and enthalpy, which have definite values at any state, heat and work do not. Heat and work are path-dependent functions. A system in general does not possess heat or work, but energy can be transferred to a system by means of heat or work. The internal energy is the grand total energy of the system. It is the sum of all the kinetic and potential contributions to the energy of all the atoms, ions, and molecules in the system. Its value depends on the temperature and, in general, the pressure. In practice, the total energy of a sample is unknown, or difficult to estimate. This is because it includes the kinetic and potential energies of all the electrons, and all the components of the atomic nuclei. Nevertheless, there is no problem in dealing with the changes in internal energy, delta U. This is because the change in internal energy can be determined by measuring the energy supplied, or lost as heat or as work. Therefore, all practical applications of thermodynamics deal with change in internal energy, and not with the internal energy itself. To treat the thermodynamic properties in a mathematical equation, we need to learn the sign convention of them. If heat flows into the system, it takes a positive sign. If it flows out of the system, then its sign is negative. Mass takes a negative sign if it flows out of the system. It takes positive signs if it flows into the system. Note that heat and mass have the same sign. If the system does work, that means flows out of the system, it is positive. If work is done on the system, then it is negative. Here, heat and work have the opposite sign. Note that the sign convention for the work used by the chemists and engineers is opposite. In engineering, when the system does work, it is producing positive work. However, in chemistry, if the system does work, its internal energy is decreasing, and thus, the work takes negative sign in this case. Therefore, based on how we are considering, the sign can change. Please, do not get confused. In my course, I am following the engineering way, that is, if the system does work, it is given the positive sign. For more details on the specific heat and latent heat, I recommend you to watch my previous videos. The links are given in the description. Thank you, and see you in the next class.